Hello, my name is Patrick, and now I will give you a first look on our work Can Machines Help Us answering question 16 in Datasheets, and in turn reflecting on inappropriate content, which focuses on documenting inappropriate content of vision datasets. As you can see, our work is inspired by datasheets for datasets. The goal is to increase transparency and accountability within the machine learning community and help users to select more appropriate datasets for their chosen tasks. With our work, we focus on a semi-automated approach to answer question 16 in datasheets, which we summarize as contained inappropriate content. But before I introduce you to our approach, let me illustrate why documenting datasets is so important for not only dataset creators, but also users. So people who want to train a specific model and look for appropriate datasets, and also users who want to use a specific pre-trained model. We know of several issues of large-scale models. One is based on the fact that you need a huge amount of data to train these models. And in most cases, these datasets are under-curated. For example, this generative example here. This is a generative model trained on uncurated datasets. It enables us to generate images by prompting text. If you prompt, for example, the word soul, you get this result. But since we can prompt any text, we could also misuse the model and try to generate something offensive. For instance, something like this. Luckily, we get an error message because the application prevents showing the output by validating the content of the generated images. Actually, the creators of this application use the inappropriate content detector, which is part of our Q16 approach. However, the disadvantage of such post-hoc validation is that we are not able to prompt specific content which seems not offensive in nature, but the content of the related training data may suggest something else. In this case, the user should have picked another dataset or picked another pre-trained model if they want to deploy the system. Proper documentation of datasets and dataset references for pre-trained models would help the user in these decisions. But recent machine learning datasets tend to become larger and larger. In turn, complete manual documentation becomes unfeasible. So to assist creators, we ask the question of whether a machine can help us reflect on inappropriate content. To this end, we propose to use the information stored in pre-trained transformer models. Our approach consists of two parts. In the first step, we make use of the pre-trained model clip as a content detection, pre-selecting potential inappropriate content. The second step documents this content. Next to the datasets annotation, we also use another large-scale pre-trained model, the caption generation model MAGMA. This model generates captions describing the identified concepts contained in the data. Regarding detection, we do not provide the first approach to detect inappropriate content. The typical example you will find in current documentations is pornographic content. However, we focus on a broader range, including, for example, not only persons, but also objects and symbols, and further concepts, such as harm. We applied our Q16, including the detection and documentation on two popular vision datasets, ImageNet and OpenImages, and documented several, depending on the task, potentially inappropriate concepts. To further point the user to specific inappropriate concepts, we applied a weighting to the descriptions by giving more weight to concepts we do not see in the corresponding appropriate subset. We visualize the most frequent descriptions as word clouds. Potentially inappropriate concepts like blood, execution, or dead body can now be traced back to the corresponding images to assist documentation. Thank you so much for listening to this talk, and you can find more details in our paper. You can also try out our code or play around with the detector on the line 5B dataset, which started to employ our Q16 approach and provides a nice web interface to explore the dataset.